Hi there and welcome back to part 2 of your virtual fish tank. This tutorial continues on from the previous one where I used the flocking algorithm to create some behavior in some simple fish models. So here's our fish models here. You can see that they're flocking and they also have some minds of their own, and you can see that they'll swim off in different directions as well. Now what I've done since the last tutorial is that I've switched the camera around to be looking down the x-axis. Now I've only done that to make it look like that we're looking inside a fish tank, a square fish tank. If you have an ocean sort of view, it doesn't really matter where you look at them from because the flocking algorithm is three-dimensional, so they'll just swim around regardless. Okay, so the first thing I'm going to do is put some sand on this ground. So the ground plane, I think it was called plane before. I've just renamed it to ground. And I've put on it a specular shader called sand. And I've also grabbed a few textures. So from textures.com, I've grabbed if I can find it, I think it's in materials. Yep, a sand texture that looks like that. So let's just select ground and put this sand texture on to there. And I've also grabbed a normal map for just a little bit of definition. So I'll take that and I'll put that onto our normal map there. It was a very subtle shift as I added it, you might have seen. To create a normal map is not all that easy. Even if you're really good at Photoshop, and that's quite difficult. And there's a number of different tools out there that will create normal maps for you. And I found one that is online, so you can add your albedo map or your diffuse map, whatever you want to call it, and then you just tweak some settings. And I'll just see if I can pull that up for you to have a look. Here we go. Okay, so the sandy soil texture I got from textures.com, and you can sign up and get free images every day. They also have seamless textures that you can download. So that's the one that I grabbed. And then I went to this website here. If you do a Google for normal map online, you should find it because it's got a really weird URL. It's cpetry.github.io. And then you drag in your texture into here and it will create a normal map, displacement map, a specular, ambient occlusion, tongue-tied today. And you can see the results in this window. And you can change the strength and how much blurred sharp it is, and you can see the effects over here. So I had that ramped up for mine and had this blur down a little bit just to give it smoother edges. Then you click on download and you've got your normal map. So that's a really great free resource. Okay, let's go back into here. Right, so now when we press play, of course nothing has changed except now we have some ground. And if you don't have any shadows on your fish, then you can turn that on the light, which is here, directional light, and then you have a shadows setting. You can have soft or hard shadows or no shadows whatsoever. It's up to you on the look that you want for that. All right, so that's looking a little bit better. Now, a really nice effect to add to get some sort of depth and a feeling of there's some water, so that's sort of a thick atmosphere, is to put on some fog. Now, I don't know if you've tried to turn fog on lately, but in Unity it's become quite a challenge. If you go to Window and Lighting, you'll see, if I go down the bottom, this little tick box for fog, which as far as I'm concerned does really nothing. And most of the stuff on the forum tells you to use the global fog script, which does something really weird with my camera, and I got lines across the screen. Now, I don't know why Unity did this, and this is a real bugbear of mine, but that's just the way it is, because fog has been something that's been around since the beginning of computer graphics. Anyway, enough bitching about that. The way to get around it and to get back our old fog settings that we used to have access to is to use script. So they are still there. Okay, so I will set that up in, if I go to my fish manager to find my global flock script, here it is here. Now, nothing has changed in this from before, except that I've now got 50 fish swimming around, and before we had, was it 20? I can't remember, a smaller number, but you can play around with that size of how many fish you want. Of course, the more fish you have, the more processing power it's going to require, but, you know, works quite well with 50. Now, let's turn on this fog. You can access the fog through this code just here, and I'll uncomment it for you. So in the render settings construct, we can still access fog color, fog density, and turn the fog on. So I'm just adding these 3 lines. If you want to have a look at what else you can do in the render settings that seem to have vanished from the editor, this stuff is still there in the scripting manual. Now, when you add fog to a system, you can't have a skybox or anything because the fog doesn't get applied to the skybox. It only gets applied to geometry. So that means that the background color that you're using for your camera needs to be the same color as your fog so that they blend together into the distance. So to make that really easy, I've set the fog color to whatever I've got my camera background color set to. So I could set it to pink, and then this will create pink fog. Then I set up the density of the fog. Now this fog is very sensitive, and I've found that 0.03 is pretty good. Once you get higher than that, the whole thing is just fog, you can't see it. And then we set fog to true, which will turn the effect on. So let's save it and go back and have a look. Now, just before I run it, let's go to the main camera and have a look at the background color. So I've already set it to this blue color, and I've made it a solid color instead of a skybox, so that this will be the color of the fog. Okay, so when we run it, it now adds that nice fog effect in, and it will gradiate over towards the camera so that things in the back are more into the fog. Which is the kind of the effect that you want, because when you look through water you can't see forever. It does get thicker and things get more blurred. Okay, so that's a really good looking effect. Now, to have the fish stay within a certain area, in the last tutorial we restricted their movement by testing how far away they were from the origin point, and then if they were, bringing them back to the center. Now this becomes a little bit restrictive when we want to start having the fish run into other objects and actually go around them. So we should treat the sides of our tank as a collision point, the same as we would treat a rock if we put a rock in here as a collision point, and make the fish actually turn around if they run into that point. So we were making them turn around before. If they swam too far away from the origin, they would then turn around and come back again. But now, instead of testing the distance from the origin, we will test if they run into the sides of the tank. Now, to create a tank, it's very easy just to add in a whole bunch of cubes, okay, and make them tank sized. So imagine them, they're like the glass wall of the tank. So there's one wall. If I drag that right back as far as I want to go, it's up to you. And it comes with a collider already, these cubes, which is here. But we can turn off the mesh renderer, sorry, or you could actually delete it completely. It's nice to have it on while you're constructing the tank from these cubes, because then you can see where they are. So I can just, with that cube, I can go Control D, which will duplicate it, and then bring that forward. Just go around a bit. You can now see I've got these 2 walls, and then I can duplicate it and rotate and put one there and on the top, and you want one on the bottom. So you want a full enclosed cube. Now I've already done this before, and so I'll just delete those I made a prefab, which I called tank. There it is, and I'll just drop that in. So here's my tank. I've got the mesh renderers turned off. These are the cubes. I've put them all together so that you can see them there. Now, before each side of this tank is going to work with our new fish code, you need to add a rigid body to each one of the sides and the top and the bottom, and turn on is kinematic and turn off the gravity, because we don't want our tank to disappear. We're just basically using it as a trigger point on the fish code to make the fish turn around. So it's important that you add these rigid bodies to each side of the tank. Okay, so that's our enclosure. Now let's have a look how the code has changed to cater for running into things. So this is our flock code. It's changed a little bit since the previous one, so I'll just go through it slowly. As you'll see, I've added min and max variables at the top for the speed of the fish. This was because I got really sick of going back through the code and changing it every time when I was playing around with the fish speed. So feel free to add this, and you could make them public if you want to play around with the speeds from inside the editor. Everything else is the same, I'm pretty sure. Okay, let's go down to the start function. Now, before each fish was swimming at the same animation speed, so they were all in perfect sync, their tails moved. Now, you might not have noticed this originally, but after you sit there and look at it for a while, they start to look a bit weird because they are all perfect clones of each other. What I thought would be nice is if we use the speed that you're calculating for the fish to actually control how fast the tail of the fish is swimming. So by grabbing hold of the animation of the fish, which is just the fish swimming its tail back and forward, we set the speed of that animation to the speed that the fish is traveling forward at, and it actually will give you a better effect, a more realistic effect. Now, the most important part of this code, since we've added the tank colliders in, are these two functions. So we're going to use on trigger enters and on trigger exits to detect, first of all, when the fish actually hits the tank edge, and then when the fish is leaving the tank edge. So what's happening here on entering the collider, if the fish wasn't turning before, then we're going to set a new goal pos for the fish. And that goal pos is going to be somewhere in the other direction behind the fish. So we're taking the fish's position and minusing the position of the object that the fish hit. And that will give us a position that's somewhere now behind the fish, and it'll cause that fish to turn around. We don't want to keep running this if this on trigger enter keeps triggering. So that's why we're only doing it once. The first time it comes through when turning is false, this will run. Turning is then set to true, which will cause this not to keep updating itself if it happens to go into that enter function. Now, the fish, as it's turning, it's always moving forward. So at some point the fish is going to turn around, move forward, and be outside of the side of the tank, the collider. So at that point on trigger exit, when you're no longer inside a collider, set turning back to false. And when you're not turning, if you remember back to the previous tutorial, the code from that is that it will then go back into the flocking algorithm. All right, now update has changed a little bit. So let's just go down and have a look at that. The part at the top that was testing about the distance between the fish's location and the center, the origin, it's all gone. So now we're just going to go, if we're turning, then we do the slurp, which will turn the fish around. And the new direction that we're turning to rotate towards is calculated between the new position and the current fish position. and the new position is behind the fish, so this will actually cause the fish to turn around. Okay, the speed at this point as it's turning is updated to some random value, which gives us a little bit of unpredictable movement in the fish, so it just doesn't look so boring and static. And then when the speed is updated, we need to also remember to update that motion, the animation in that fish. Okay, then we go into our else, which is the same as before. I've actually increased this value here. I think I had 5 before for the number of times we do apply rules. So I'm just doing it sort of 1 in 10 now. Now, someone on the forum actually said that we could use an invoke repeating to do this apply rules, which you could, of course, do an invoke repeating at sort of random intervals to run the apply rules. But this works the same. And then finally, we have our translate, which is constantly pushing our fish forward. All right, so that's the update function. It's a lot shorter than it was before. And then finally, we have our apply rules function. And I really don't think there's anything that has changed in this, but I'll just go through and you can have a look by pausing the video just to check your own code against this. I think it looks pretty much the same. I might have changed like this distance here for the avoidance of the fish. So if you increase the size of the fish model and they start to look like they're actually all on top of each other and in overlapping their models, then you need to increase this here, because this is this section that's going to make the fish turn away from each other if they have essentially collided or crossed over each other's paths. Okay, going down a bit further, this is a new line again because we're changing the speed of our fish to the average speed of the group that it's in, and I want to set its animation again to that speed. All right, so that's all of the code. Good. So let's save that and come back and run it, and then watch the fish. So this fish here, for example, he's going to go off the screen, but he eventually will hit the side of the tank. If we can see him down in the scene view. Oh, he just did. He just turned around and he's now heading back in. Same with this fish here. He will hit the walls and come back again. And you can see that behavior is working quite nicely for these fish. So remember, if you want a tight flocking group of fish and they don't have a lot of wanderers like this lot here, you can change the neighborhood distance, the neighbor distance that's in that flock script, and which will then encompass more fish around them to make them flock. If you wanted to create fish that don't care too much about being together in a school, then you could make that neighbor distance actually really quite small, so that maybe only 2 of them will swim together at any one time. Okay, so they're all nicely staying in our tank. Okay, so that's pretty much the code finished for this. Now it's time to do a little bit of decorating and make our tank look good. So I had a bit of a look around on the asset store and I found a bunch of free rocks that I could use, so I've imported those in. And I made a prefab of my setup. Just drag that over here. There. To save you the pains of watching me resize and drag these around. So they just sort of fit nicely, and there's a whole bunch of rocks under here. This was a really nice little free rock kit that came out. And I also found this idol model, which I thought was pretty cool. Let's just bring him in. Now, he's actually enormous. There he is there. So we need to bring him down to scale a bit. And if I just click on him in here, I can then just move him around to wherever I would like. Bury him in the sand a little bit. Rotate him around. Put him over there. Okay, so if you have a look at this idol, it hasn't got a collider on it. Now, if you want the fish to turn and not swim through him, if we just run this now, they will, because we're not asking them not to. Of course, because I'm recording this, they're probably going to swim off in a completely different direction and go nowhere near him. Oh, we might get lucky. No, I'll just try again. Here they go. Are they going to swim through? No, of course not. They look like they're avoiding him, but trust me, they're not. Let me just move him right into the smack bang in the center of everything. And, okay, now we can see the fish actually swimming through him because it's as though he's not there. Okay, so I'm just going to move him back. Let's put him there. All right, so we need to add a physics box collider, and it's the right size. If you end up with something that seems to be the wrong size for the object that you're adding your box collider to, remember that you can resize it with these values in the inspector, but he's pretty good to go. And remember, I said for the tank sides, you also need to add a rigid body and turn off the gravity and make it is kinematic. Okay, so now he's all set up. The fish should avoid him. So let's play this and see if we can get some fish that turn around when they come over. I should have kept him in the center, shouldn't I? Of course, they're going to just avoid him anyway because I'm trying to show you how it's working. Okay, here we go. Okay, so some of them are coming up to it. Yep, and they hit the edge of it and they're all turning around and going off in the other way. So you can add all sorts of things, ornaments in your tank, and the fish will automatically avoid them as long as you remember to add a collider and the is kinematic rigid body without gravity. So they're turning really nicely. Next, we're going to add a really cool effect, which is caustics. Caustics are the patterns you get like on the bottom of the sea or the bottom of a swimming pool when light comes through the water and hits it. The caustics are also if you shine a torch or a light through a glass of water and you get the brilliant colors on the surface. Now, to do that, in Unity, there's a few different methods. You could get a shader that does it. You probably do it procedurally, but I hate to think about the code for that. Or you can do a bit of fakery, as I'm going to do now. I'm going to use a projector object, which will project an image onto all of the objects that fall within its volume. Okay, it's kind of like a movie projector. Anything that gets in the road is going to get the image that's being projected. So we will create an empty object, and I'm going to call that Caustics, which is C-A-U-S-T-I-C-S, Caustics, if you're interested in Googling it to see what it actually is. Now we're going to add a projector object, so I'll just do a search for projector, and there's our projector object. Now the projector object, if we just go back to the scene view here, you'll see that you have the pyramid shape of a perspective type view projection going on, and it's projecting it that direction. We want to project it down. So we can rotate that around our red axis here by 90 degrees. So let's just grab our rotation around the X 90 degrees. So now it's downwards, and I don't know if you can see that very clearly on the video, but whatever's inside of that view volume, I guess, of that projector is going to get the image applied to it, the image we haven't set up yet. Now, our tank is basically, square rectangular prism. So instead of having a perspective type projector, we can set it to be orthographic by ticking this box. You'll see that it's now become a rectangular prism, and it's only going over this little area of our tank. So you might want to actually increase the orthographic size to make it fill up more of the tank, and you can move it around later depending on what the camera is actually seeing in the view there. Alright, so the caustics now needs this image attached, and I created a caustic material before. Here it is. So I'll just drop that onto our material. Now this is where it comes to setting up your material shader to be the projector light one. So once you've imported that effects package, it will become available in this list of shaders. So find projector and then go to light. Now, you might be able to see there's something already in the cookie part of the shader. Don't worry about that because I've done this before. Yours is probably going to be empty and it's just remembering what happened. You can put a static image in here, but you can't drag and drop a movie into there. And it's the movie file of the caustics that we're going to use. So to get the movie file onto our projector material, we need to write a little bit of cheeky code that's going to do that for us. I've created a C# file called Caustics, and I'm just going to drop that onto my Caustics object. And then I'll open it up and show you what's in there. It's really simple. So we've got our projector, and we've also got this public exposed movie texture, which I'm going to drag and drop a movie into. And then we grab hold of our projector at the start and we set the shadow text part of the projector material to our movie texture. Then we set the movie texture to loop and to play. And this will make the movie texture frame by frame appear on our projector material, which is fantastic. So save that, and then if you go to Caustics, your object, you'll find that this movie texture exposed variable is currently empty, and this is where we drag and drop our movie in. Now I created this caustic loop, which I'm just going to drag and drop and put that there. I'll show you the effect and then I'll talk about the caustic loop. So let's just run this. Okay, and you can see the caustic. So this is the caustics, this white light that is moving around on the surface, not only on the ground, but you can see it on the idle object and maybe not so much on the background, because it will depend on where you've got this volume of your projector. So wherever this is hitting, it's going to draw that movie texture on it. So if we, no, it's not too bad. You could make it a little bit bigger to encompass everything. And to do that, we use, remember, the orthographic size. And you can see it adjusting the texture, the first frame of that movie. As I said, once you already run it twice, it seems to remember the object that's been given to it. Okay, it depends on the sort of effect that you want. So it's definitely all over those rocks at the back. You've also got the fog going on too, so I guess that's sort of interfering, not making it as obvious. Oh, it's not too bad. You can see it there. Okay, so that's running this movie as a texture on our projector, which is giving us a really nice effect. Now you're probably wondering what that caustics video looks like. I got it from YouTube, and I'll just show you where I got it from here. Okay, so I did a search for Caustics Overlay water free. I do a lot of searching for free, and this one's really great. Okay, so if we just play it for a bit longer, it goes into the caustics, and you can see the effect here, and it's got the black and the white, which makes it perfect for putting into Unity and using that projector light shader, because the projector light shader ignores the black parts. It's like setting that black to alpha, and it will just leave the light behind. Now you can grab this yourself. I downloaded it with CC Clip Converter, which is another website, which allows you to download stuff from YouTube, and you've probably got your own ways of doing it. Then I took the movie into, what did I put into? I put into iMovie, and then I clipped the beginning, which had all of the advertising part for these guys in it, which also says, by the way, that you can use it for free. So I haven't been a bit naughty there. Anyway, and now this goes for like over a minute, and I think I've cut it down to, I think, 40 seconds or something. And it needs to be seamless, which is another problem, because if you loop through and the last frame isn't the same as the first frame, you get like this jitter effect happening. So what I did in iMovie is I took like 20 seconds of this, and then I duplicated that 20 seconds, and then the second half of the 20 seconds I reversed the timing so that the last frame of the first part was going to match the first frame of the second part, and I stitched them together, and then I saved it as an MP4 file. And that has worked brilliantly. Now, you may have other ways of doing this, but that just works for me. I did run this through After Effects and also put it out as a MP4 file, but that Unity didn't like it, and this didn't work. So obviously, it's the simplest things that usually work the best, which this does. All right, so that's Caustics. One final last thing I want to show you before ending this tutorial is how to put some sun shafts into here, or people call them God rays sometimes. So that's just the light that streams down here in the tank, just for that final touch. So there's a sun shaft script that comes with the effects that you can put onto the camera, but it doesn't give you the effect that you want in this tank setting. And besides, it's doing a lot of processing, which is not necessary. We're just going to really fake this effect. So in the hierarchy, add a plane, and we're going to then rotate that plane so it's facing the camera, which means a -90 rotation for it. And then if we select the plane and resize it, so that it fills up the screen, and move it forward so that it's at the front. You probably want it over the top of everything that you can see in the game view. And onto that, I'm going to add a texture that I created before for our sun shafts. Oh, okay, there it is. Now, you can't see it. If I zoom out a little bit, it's a bit pale, and it's actually going sideways. So I'm going to rotate this whole thing around this way so that those rays are now coming down. I might just neaten that up with an exact 90° X and 0 Y and -90 Z rotation. And then once you've done that, you can then again resize it as you need to stretch it across the screen and position it, bring it forward or back. So if we take it back here, you can see where that texture is taking over the image. Now, that texture is just a black and white image. If I can find it here, and if you can see it, this is all it is. It's just sun shafts. This was created in Photoshop, and you can create it in Photoshop if you use the difference clouds and then apply a radial blur to those difference clouds. Just Google that and you'll find a number of different people who put these effects into photographs that will give you the directions of creating that. Okay, so there's our sun shafts into our water, and if we play it, we now have this really nice effect in our tank. Depending on how big you want your tank to be, you can put more objects around here to fill it out. I'll just come back to this sort of view here, which is the full view of it. Okay, and that's pretty much it for this. So I hope you enjoyed making your fish tank and playing around with it. I certainly am going to go and try and add a few more different fish species and different objects. And you could find grass and stuff as well if you want to put that in there. I haven't gone into putting bubbles in, Bubbles are a particle system, and if you have a look in the assets for importing particle systems, there's actually a prefab for bubbles already in there, and you can just drag and drop that into your tank. I won't go through that now. Okay, well, I hope you enjoyed that. I really did enjoy it. As I said before, I really love fish tanks, and this is really peaceful to watch. So I'll talk to you in the next tutorial.